Hare Krishna. This is day 3 of October challenge. So number of good pairs this problem is all about. So we will be given one integer nums array and we need to return the number of good pairs. So how a good pair can be judged? So there is a pair ij called good pair if nums of I equal to nums of j and also I should be less than or equals to j. So if we take this example 1, 2, 3, 1, 1, 3. So there are total good pairs because the index at 0 is equal to index at 3. Let's assume like this is I, this is j. Okay, nums of I equal to nums of j and I less than j. This is one pair. And then again index 0 is equal to index 4 also. This is another pair. Then we have index 3 equal to index 4. Okay, these both are also a good pair. Then index 2, that is nothing but 3 equal to 3. That is nothing but index 5. This is also one of the good pair. So total we have 4 pairs. Now let's see how we can solve this problem. We'll take the same example 1, 2, 3, double 1, 3. Okay. 1, 2, 3, double 1, 3. This is our input array. Okay, so this problem can be solved in numerous ways. So let's take the naive approach using two loops. So basically what we can do is we can start first outer loop from here and till here. Okay, that is nothing but I equal to 0, I less than or equal to n minus 2, where n is the length of the array. So here n is 6 length. So 6 minus 2, that is nothing but 4. So till index 4 we need to traverse. Then there is the outer loop, inner loop, which can starts from here because as you know, I should be always less than j. Okay, then what we can do is j equal to I plus 1 and j less than n minus 1. Okay, where n is 6, 6 minus 1, that is nothing but here. So every time what we do is if nums of I, okay, nums of I equal to nums of j. In this case, we increment our count. So let's assume we took a count variable initially, okay, which is initially 0. So we keep on incrementing whenever we find this one. And we always know that I is going to be less than 0 because we are starting j equals to I plus 1. That means they both are not equal and j is always greater than to I. So this is one approach, okay, but with this approach, if you see the time complexity is going to be big of n square. The reason is like for every element in the outer loop, you are iterating through the every element in the inner loop, right? So the time complexity is this one, and the space complexity is going to be big of one because we are not storing this anywhere. So this is a naive approach. So can we reduce this time complexity? So yes. So with the help of HashMap, okay, HashMap, we can reduce the time complexity from big of n square to big of n. So if we carefully observe, if our input is something 1, 2, 3, 1, 1, 3, just try to understand, okay, there is a small trick. So if you know the occurrences of 1, okay, occurrences of 1 or else occurrences of 2, okay, then you are good, right? Because as we know, like if I nums of I equal to nums of j, then only they can be called a good pair. So if we know the occurrences of 1 and 3, then we are good. We found the answer. So what we are going to do here is, so let's try to understand. This is our hash map initially. Okay. So we iterate through this one, this loop. Okay. So basically what we are going to do here is, okay, so we'll check one. Is one exist already? No, right? So if it is not exist, then we'll take 0 into the consideration because it does not exist. Okay, initially our count is 0. Okay, let's assume. So 1 is not there, so we take 0 into the consideration. So 0 plus 0. So whatever you get here, okay, that plus what is the existing value of count, that is 0. So it's going to be 0. Then I'm going to insert 1 with 1 key value that indicates, okay, the one occurred one time. Okay, now I come here, is 2 exist? No. Then I take again 0 into 0, count is still 0, then count value is still 0, then 2 comma 1. Then I come here, 3 exist? No, count is still going to be 0, then 3 comma 1. Okay, then 1, is 1 already there? Yes. Then we'll take 1 this into the consideration, then we'll increase count by 1. Okay, because whatever value you are getting, 1 plus existing count value is 0, 1 plus 0 is nothing but 1. Then we'll make this 1 by 2. Okay, because 1 occurred second time also. Okay, now we'll come here. Again, 1 is there. Okay, we'll check. Yes, it's there. So what is the existing count value? It's nothing but 1, right? So 1 plus 2, that is nothing but now count value 3. Okay, then we'll increment the 1 value by 3. And at this point of time, you can see after 1 occur 3 times, we are saying count equal 3. Yes, it's correct, right? Because this can be one pair, this can be one pair, and this can be one pair. So there are total 3 pairs, 3 pairs. So we got a exact number. Then again 3. So is 3 is there? Yes. So take the 3 into consideration. So whatever the count value plus this one, whatever you are going to get 1, 3 plus 1, that is nothing but 4, and increment 3 by 2. And we end up, what I can say, reaching all the elements in the array. So now whatever the value for count, you can just return that. That is nothing but 4. That is the expected outcome of this input array. So with this, you can see the time complexity is going to be big often because you are going to iterate through the each element only once. But slight disadvantage is the space complexity also going to be big often considering the all elements may be the unique. Okay. So this is all about the second approach. We'll quickly write the code. So to save some time, so I am taking my previously submitted one. So here you see like HashMap initialized and count is 0. Then I'm iterating through each number. So I'm taking the existing, that is nothing but map.getOutDefault. So getOutDefault, what it do is if the key is already exist, it take its value. If it is does not exist, it takes 0 into the consideration. Okay, that is what I told, like 0 plus 0. Then whatever you are getting here, let's append to the, sorry, let's add to the count, and then again put this number whatever you are currently visiting by incrementing by 1. Okay, that's it, we are going. So at the end, return your count. So let's submit this one. So it got submitted successfully and it took only 1 milliseconds to run. So now I will show you the other approach also, the two loops big often. So yeah, okay, let me copy and paste this here so that we can run it. Okay, now you see how the two loops code works. So basically, I took n equals to nums dot length and counted 0. So for every element in the outer loop, for I equals 0, I less than n minus 1. Okay, and I'm saying here less than, that is nothing but I minus 2 only. Okay, I'm not saying equal to. Then I plus plus. So for every element in that, then I'm going through the inner loop where j equals to I plus 1, j less than n, j plus plus 1. So whenever I know like nums of I equal to nums of j, then I'm incrementing the count. Okay, and at the end I'm returning the count. Let's submit this also. Yeah, even this also fine. This also took 1 milliseconds and it got also executed. So two approaches are fine here. So that's all for this video and I hope you like the video. Till then, Hare Krishna.